Hello, Trig, and welcome to Graphing Sines and Cosines Part 2. So far, what we've handled is graphing things that have a period change, and that's stretching the slinky out or compressing the slinky. It changes how long it takes for it before it repeats itself. That was the definition of a period. We handled vertical translations. That's just sliding things up, sliding things down. We handled amplitude. Amplitude was a vertical stretch. How high does the thing go compared to where it starts? So we handled those three things. What we haven't handled were horizontal translations, what we call phase shifts. I gave you guys a little assignment in Chapter 1 to kind of get the ball rolling, so hopefully you remember this. If not at the end of the world, but I have a little Desmos thing, and we'll look at it real quick. So without further ado, let's open up a Desmos. And I just want to show you the idea behind horizontal translation. So let's do something that's not trigonometric. How about y equals x squared? Okay, vertical shifts are on the outside. If I add just some number, it moves everything up 5. If I subtract some number, it moves everything down 2, down 3, down 4, down 5. You get the idea. But now when we're just affecting the x coordinate, we're going to need some parentheses here. And actually, I'll start a new one. Y equals x minus 1 squared. And intuitively, you would think, ooh, minuses go to the left, so this should go to the left. But that's not the way it works. The order of operations and what we're doing to our x-coordinates before we square it, it's actually causing all of our points to move to the right. So here was the initial point, the initial vertex, 0, 0. Now here it is after a translation. Now it's 1, 0. A minus 1 in here actually moved everything to the right. Okay, a minus 4, everything 4. If I put a plus, what's going to happen? It moves it to the left. So pluses the inside of our function, just to the x-coordinate, move things to the left and right. If it's a plus, it's to the left. If it's a minus, it's to the right. And it works with sines and cosines too. So let's turn this one off. And let's just really quickly look at y equals the sine of x. Okay. How about y equals the sine of x plus 1? Okay, here was the point to begin with at the origin, 0, 0. Here's the point after I shifted it, negative 1, 0. A plus 1 inside of this function actually moved all my points to the left 1. Okay, same thing works with minus. Minus would actually move the purple one to the right, and that's what we're talking about, phase shifts. So we need to be able to now graph phase shifts. So let's take a look at that. Situated. So I'm just going to jump us straight to an example. An example looks like this. Y equals 1/2 sine of x minus pi over 3. The first thing we are noticing, just like I did on that Desmos, is I'm doing something just to the x-coordinate. In this case, I'm adding or subtracting. That's how we know there's a phase shift. If I see a plus or minus inside of these parentheses just to the x-coordinate, that tells me there's a phase shift. Okay? How we start to graph these is no different than how we started to graph the other ones. We have to find the period first. We find the period by doing 2 pi over b. b is still the number that we're multiplying out in front of this x. So in this case, b would just be 1. So we're doing 2 pi over 1. The period is still 2 pi. Okay, from here, let's keep running with this. If there wasn't a phase shift, what would I do? Well, I would break up my x-axis into our key features, our key points, if you will, where we broke up 2 pi into 4 equal lengths, into fourths. Okay, so for this, I would take half of that. Here's 2 pi, half of that would be pi, half of that would be pi over 2, and then I want 3 of those. So 1 pi over 2, 2 pi over 2, 3 pi over 2. Those are my key values. That's going around the circle once, hitting those nice cardinal directions. When I plug this stuff in, it would usually be nice and easy for us. But hopefully we can see that isn't the case. If I try to just go plug in a 0 right now, 0 minus pi over 3 is negative pi over 3. The sine of negative pi over 3, yes, we could do that. We did a whole unit and unit test on that so far. But it's not on the cardinal directions. And I told you guys at the beginning of this, if you follow my lead here, if you follow these instructions, I will always only make you take the sine or cosine of those cardinal directions. So what needs to happen? You kind of already see it down there. We need to move all the values. We need to shift all the values by whatever the phase shift is. Now, we got to be careful with this. I'm trying to head off a problem that happens down the road. This is not actually our phase shift. That's just the C value. The phase shift, our formula for phase shift, was always C over B. We'll write it right here. So the phase shift will always equal C value over the B value. In this case, since the B value, we already talked about it, is 1, yeah, it is. It's pi over 3 over 1. Pi over 3 over 1. The phase shift is pi over 3. But that won't always be the case. Sometimes there'll be a number here, and we'll have to deal with that, and that's going to be our next section note. So let's keep going with this. The phase shift, we have to shift it over by however much the phase shift is. We just said the phase shift is pi over 3 over 1. So it is. It's pi over 3. Now, all these key x values, like I just showed you on the Desmos, they're not there anymore. They're moved. They need to be shifted by pi over 3. And because this is a minus sign, we're actually shifting all of our points to the right pi over 3. I need to add. I know it says minus here, but we're doing the opposite. I need to add pi over 3 to each one of these key values. So this takes a little bit of doing it first, but after you get used to it, more of that pattern recognition we talked about before, it really isn't that bad. So what can I cover here that you can still see what I need you to see? How about that? So there's the first one. 0 plus pi over 3, pi over 3. Next one, got to add some fractions. Pi over 2 plus pi over 3. Okay, well I would need a common denominator. That would be multiply these by 3, multiply these by 3, multiply these by 2. It would be 3 pi over 6 plus 2 pi over 6. It is. It's 5 pi over 6. Okay. The next one, I need to add pi plus pi over 3. Okay, more common denominator stuff. 3 pi over 3 plus 1 pi over 3, 4 pi over 3. And usually from right there, I usually stop and I continue this pattern. This was today's bell work, by the way. This is 1 pi over 3, or actually this is 1 pi over 3, which is 2 pi over 6, 5 pi over 6, 8 pi over 6. Are you picking up what I'm laying down? It's just increasing by 3 pi's over 6 each time. It's that pi over 2 we were talking about. But I'm going to increase this by 3 pi over 6 each time to continue my pattern. So I continue my pattern. It looks something like this. Now these are actually the values that we are going to graph. We're actually going to put on our graph. Pi over 3 is my first x coordinate. So all these values we got right here are actually the x values on our points. So just like before, we would start jamming these into the function one by one. We're jamming these into the function one by one, and that's where we're going to hopefully see those key values. So let's bring back the equation. The equation looks like this. Here's my first x value I'm going to plug in, pi over 3. Okay, pi over 3 minus pi over 3, that's 0. Awesome, because I have to take the sine of 0. Sine of 0 is 0. 0 times a half, 0. There's our first point we will put on our graph. Next one, I'm plugging in 5 pi over 6. Okay, more fraction work. Got to get good at fractions. 5 pi over 6 minus 2 pi over 6. This is 2 pi over 6, by the way. That would be 3 pi over 6. Okay, 3 pi over 6. That pi over 2. That's 90 degrees. The sine of 90 degrees, the sine of pi over 2 is 1. Okay, 1 times a half is a half. Awesome. And we can just keep plugging these in one by one until we get the pattern. And if we know the pattern, if we know how sine works, if we've done enough of these, hopefully you have to this point, we know it's going to go the midpoint, then it's going to go up to a max, then it's going to go back to a midpoint, then it's going to go down to a minimum, then it's going to go back to the midpoint. So mid, max, mid, min. Mid, max, mid, min. We could just keep going down the line with our pattern recognition if we want 2 periods, which we do, and then graph this thing. We graph those points, and we're dancing. So here's me going through the pattern. Remember, to get 2 full periods, we need 0 is the first one. So I would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. That's right. I was thinking it was 9 points. Let's look. Let's graph it. There's plotting those points. All I did was plug these points we got up here onto a graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. I was wrong. It was. Oh, yeah, it is. 10 is 1 too many if I want 2 full periods. From here to here is 1 full period. From here to here is another full period. 9 points is actually how many we need. I went a little bit over. But that's okay. We slid all of our key features over. If the graph said something about starting at 0, we might have to go backwards and fill in this gap. But if it just says 2 full periods, we can put those 2 full periods wherever we want. All right. So before I give you the stamp, and if you looked at the stamp, that's okay. Why don't you try this problem? Graph one period of this. Hit pause, go through the steps, see what you can come up with, come back, and I'll run us through it. Okay, we're back. I don't know if you hit pause. I hope you did, but let's go with it. So I want to graph one period of 3 cosine x plus pi over 4 plus 2. I recognize a phase shift, so I'm going to have to adjust my x values. Well, what x values are we talking about? Okay, I got to find the period first. The period is 2 pi over b. b is 1, so 2 pi over 1 is 2 pi. So my usual suspects would be 0 to 2 pi, half of that, 3 of those. So those would normally be my key suspects, but because there's a phase shift, we're going to do the opposite. So let's see, the phase shift in this case is c, which is pi over 4, over b. It is pi over 4 in this case because this is a 1. It won't always be that way, but it is here. And then I'm going to do the opposite. I'm going to do the opposite of phase shift. Instead of plus pi over 4, I'm going to subtract pi over 4 from all of these values to get my real key features, what I'm actually going to put on my graph. 0 minus pi over 4. Oh, I like that one. That's negative pi over 4. That's going to be the first one. Next one, pi over 2 minus pi over 4. Okay, so that's 2 pi over 4 minus pi over 4. All right, pi over 2, I multiply the top and bottom by 2 to get common denominators. 2 pi over 4 minus 1 pi over 4 is just a positive pi over 4. And actually from there, well, we'll do one more. This next one, 4 pi over 4 minus 1 pi over 4. That would be 3 pi over 4. Okay. Now from here, let's go ahead and continue the pattern. This was a negative 1 pi over 4 to a positive 1 pi over 4 to a 3 pi over 4 to a 5 pi over 4 to a 7 pi over 4. Right? I'm just adding. No, I'm good. Add 2, add 2, add 2, add 2. And always, when you get into, if you're not sure if this works, like the little pattern recognition, you can always just plug in a number. We could come up here and plug 7 pi over 4 in here. 7 pi over 4 plus 1 pi over 4, that would be 8 pi over 4. 8 pi's over 4, that's 2 pi. Oh, okay, good. That is a key value. Cosine of 2 pi is 1. 1 times 3 is 3. 3 plus 2 is 5. I know I'm going to get a 5 here. Okay, but let's keep going with cosine. This is a positive amplitude. Well, they're always positive amplitudes. So this is a positive a value. So I know my cosine is going to start at a maximum. Okay, let's plug in negative pi over 4. Negative pi over 4 plus pi over 4 is 0. Cosine of 0 is 1. 1 times 3 is 3. 3 plus 2 is 5. Next one, pi over 4. Pi over 4 plus pi over 4. That's 2 pi over 4. That's pi over 2. 90 degrees. Cosine of pi over 2, 0. Times 3, 0. Plus 2, 2. Okay? So cosine, maximum, mid, minimum, mid, maximum. We could do this one if we need to, but I saw it dropping by 3. So that's my change each time. I know it's going to drop by 3, drop by 3, increase by 3, increase by 3. Again, if we're not good enough with that yet, we can plug this in. 3 pi over 4 plus pi over 4 is 4 pi over 4. 4 pi over 4 is just pi. The cosine of pi is negative 1. Negative 1 times 3 is negative 3. Negative 3 plus 2, it is negative 1. So to wrap all this up in a bow, we're going to plot these. Here is negative pi over 4. Here is pi over 4. Here is 3 pi over 4. 5 pi over 4. 7 pi over 4. One period of this, negative pi over 4, which should be up here at positive 5. Pi over 4 should be at 2. 3 pi over 4 should be at negative 1. 5 pi over 4 should be at 2. 7 pi over 4 should be back at 5. We're always flat at these maxes and mins. So I'm going to start by going straight to the right before I drop. Straight to the right, then drop. Just a curve drawing type of thing. Even that one wasn't very good, but we get the idea. It's not a fashion show. Okay, there it is. Here's your guys' stamp. We're practicing graphing with a phase change. Page 412, 49 through 52, 57, and 58. They're all the same, practicing with a phase change. Do your best. Bring your questions to me, and we're almost done. We got one more part of this. Man, this is 4-5 is big. Peace. Moving on.